Hello dear students, today I will discuss about permutations. Okay, just in the previous class I have already discussed about multiplication principle of counting. Okay, so events can occur followed by other events. The number of ways in which the 2 or 3 or 4 events can occur in a number of ways which can be found by multiplication principle. Okay, so here permutation means, suppose we are having some numbers or some objects. For example, suppose we are having 1, 2 and 3. These are 3 numbers are there, 3 objects. So just we have to select these 3 objects in a particular order. Then how many combination will be there? In a particular order. Okay, so just suppose first take 1, then 2, then 3, 2, 1, then 3, 3, 1, then 2. Just we can do it. Means if we select all the objects, all the numbers, that is 3 numbers, that is 3 places are there. First place can be filled by with any of the number, but only not selecting in a definite order also. So if we select first 1, then we can select 2 or 3, 2, then 3. If we select first 1, then 3, then 2. We can select first what? 2, and then 1, then 3, 2, then 3, then 1, 3, then 1, then 2, and 3, then 2, then 1. Okay. So we have 3 objects, 3 numbers, and select 3 numbers in a different order. Order is mentioned. Clear? This. If we consider the order in which we select the numbers, then how many combinations are there? 1, 2, 3, 4, 5, 6. 6 combinations are there. Okay. This is called permutations. Not only selecting. From 3 objects we can select 3 objects in different order, then 6 combination will be there. Now only selecting 3, then there are 3 options are there. Okay. So here what is this type of combination is called permutation. That is the arrangement of objects in a definite order. Arrangement of objects in a different order. Just suppose 1, 2, 3 are the numbers. We select only 2 numbers from this. So you can select 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2, 1, 3, 3, 1, 2, 3, 3, 2, 1, 2, 2, 1. This can be the objects. There are three combinations. Okay. Selecting two objects from three objects. Okay. So this is selecting two objects from three objects in a definite order, the number of, but if we omit the order in which we take it, then 1 2 2 1 will be single, 3 1 1 3 will be single, 2 3 3, there is 3. Okay, so we can select objects from given number of objects. Either we can select all the objects or some of the objects in a definite order. That in a definite order, and that type of arrangements of the objects in a definite order is called permutations. That is, permutation is what? Permutation is arrangements of a number of objects in a different definite order. In a definite order, the number of objects taken all at a time or some of the objects at a time from them. Okay. So just permutation. Now, if our given objects or numbers are distinct, maybe 1 2 3, maybe 1 1 3 2 are same, just A B C or A C, these are three objects. Here two objects are same, here two numbers are same. So if objects are distinct, then how many combinations are possible? In how many ways we can arrange the required number of objects from a given number of objects. Clear? So here permutations means arrangements. Now permutations, when all the objects are distinct, different type of object. Suppose we are given n objects, A1, A2 and up to, how many objects are there? N objects. All are distinct. All are distinct. Clear? Now we want to select, that is here we can write like this: AI are objects, I equals to what? 1 2 3 and so on, up to how many objects? N objects. In between, suppose there are R objects, N objects. If 1 2 3 4 up to R, then R plus 1, and then R minus 1. These are the counting. Okay. How many objects are there? N objects. And we have to select, and also AI is not equals to AJ. I equals to J equals to 1, 2, 3 and so on. For same. For distinct, not equals. So distinct objects. Okay. Here, these all are the distinct objects. Now, just R means what? R is a number which is greater than 0, is less than equal n. Maybe one objects greater than 0, maybe one objects, maybe two objects, maybe three objects, maybe equals to n objects. R is less than equal n but greater than 0 here. So, how many places are there? 1, 2, 3, 4, 5, 6, 7 up to R places. Because we want to select R objects from N objects. R is less than equal to N. So first object, because all the objects are distinct, so first place can be filled with how many techniques? There are N objects, distinct objects. So take any of the objects. So first position can be filled by n ways. Now if repetition is not allowed, repetition is not allowed, then how many objects are remaining? One object already selected by multiplication rule. Then second place can be filled by, because then one object is already selected, so remaining n minus 1 elements, n minus 1 objects, so remaining position can be filled with n minus 1 ways into because multiplication rule. Third place can be filled with n minus 2 techniques. Similarly, how many places are there? R places. R places. So first place, second place, third place up to R place. In first place, n minus, first place n minus 0, second place n minus 1, third place n minus 2, rth place n r minus 1. Clear? So here in rth place n minus r minus 1. So this product is given the number of ways in which we can select r objects from n distinct objects when repetition is not allowed. Clear? And this is called permutation. Number of ways in which we can select and arrange in a definite order. Number of ways in which we can select and arrange R objects. Arrange R objects. R objects in a definite order from n distinct objects. We can select and arrange R objects in a definite order from n distinct objects where repetition is not allowed, and it is denoted by NPR. NPR, and it is denoted by and this is denoted by this. Number of ways in which we can select and arrange R objects in a definite order from n of distinct objects when repetition is not allowed, and it is denoted by NPR, that is arrangements of R objects from n distinct objects. Okay, this is our notation NPR. What does mean NPR? From n objects we select R objects and arrange in a definite order. That is the arrangement of R objects from N objects, N distinct objects. Okay, NPR is this. That is NPR equals to this. That means we get NPR equals to N minus 1, N minus 2 up to N minus R minus 1. So generally write N minus 1, N minus 2 up to here N minus R plus 1. This is the value of NPR. Arrangements of R objects from N objects. Okay. So this is important formula. So note down this. Okay. Now we can use factorial notation. Okay. Factorial notation for finding the value of NPR. Okay. For finding the value of NPR. So how can we get that formula? So first of all, we have to discuss about factorial notation. Factorial notation. Factorial notation. Factorial notation. Factorial notation is very simple. Suppose n is a positive integer, then n is a positive integer, then either we can write like this factorial n, or also we can write factorial n line exclamation mark n. This is factorial n. Factorial n. We can use this symbol or this symbol. And what is this? If n is a positive integer or natural number, then we can write like this, n equals to. So just product of first n natural number. So 1 into 2 into 3 into 4 up to n. That is factorial n equals to what? 1 into 2 into 3 into 4 into up to n into. For example, factorial 4 equals to what? 1 into 2 into 3 into 4. That is into. This is means multiplication. 1 into 2 into 4 means 1 into 2 to 6, 6, 24. So factorial 3 means what? 1 into 2 into 3 means 6. Factorial 2 means what? 1 into 2 means what? 2. Factorial 1 is equal to 1. So multiplication. This is the what? Multiplication. Multiplication. Up to this. Just we can write like this. Okay. Multiplication. These are the multiplication. Clear? Multiplication. This is the factorial notation. Clear? So here we can see that factorial 2 equals to 1 into 2. Clear? So here we can see that 1 can be written as factorial 1. So factorial 2 can be written how? 2 into 1 factorial. Because 2 into 1 factorial. Similarly, factorial 3 equals to 3 into 1 to 2, 2 factorial. 3 into 2 factorial. Similarly, factorial 4 equals to 4 into this factorial 3. So factorial 4 equals to 4 into factorial 4 equals to 4 into 3 factorial. That is, if we have factorial n, then we can write n into factorial n minus 1, 1 less. Just like this. That is, factorial n can be written n into n minus 1 factorial. This is n minus 1 factorial. Also, we can write n minus 1 into n minus 2 factorial. This is the notation. So helpful for for finding the value of NPR. Okay, so this notation is very useful notation. So on the basis of this notation, the exercise 7.2 is given in your book. Okay, just solving that questions we can understand better the factorial notation. Okay, so take questions from exercise 7.2. So 7.2 question first, 1 and 2, 8 factorial, 4 factorial minus 3 factorial. So solution, 1 first, just factorial 8, we have to find the value of factorial 8. Clear? 7.2 exercise, just very simple. It is not just like only multiplication. Evaluate the value of 8 factorial. Okay, 8 factorial and 4 factorial minus 3 factorial. So 8 factorial means what? 8 into, just we can write in reverse order also, just like this. Suppose n factorial, then we can write from n this in reverse order. That means 4 means what? 4 into 2, 3 into 2 into 1. Here n into n minus 1, just 1 less multiplication up to n 1. Okay, so this is the process of writing. So here we can write how? 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. 8 factorial means this. So we can multiply is 56 into 30 into 24, 76 into. Okay, now we can multiply 56 into 72. Four zero 320. So this is the way. Just multiply. Okay. So very useful, because 40320. Just second, what? Factorial 4 minus factorial 3. Factorial 4 minus factorial 3. So how can we solve it? Factorial 4 means what? 4 into 3 into 2 into 1 minus 3 into 2 into 1. So we can write 6. Sorry. What? 24 minus 6. 18. Clear? Question second of the exercise. What? Say, is 3 factorial 4 factorial plus equals to 7? 3 factorial plus 4 factorial is equals to 7 factorial. Is this or not? No. This type of relation is not hold. Just we can see it. 3 factorial 4 factorial means left hand side is equals to what? 3 into 2 into 1 plus 4 into 2 into 3 into 2 into 1 equals to what? 6 plus 30. And right hand side 7 factorial. 7 into 6 into 5 into 4 into 3 into 2 into 1. When 42 into, just we can see that 30, there 42 into 120. So left hand side is not equals right hand side. That is no, not true. But just for finding values of factorial, just you have to practice for finding value of factorial. Similarly, question third, you can see what says in question third. Compute 8 factorial upon 6 factorial into 2 factorial. So this type of questions is important Just for important calculation of NPR. How can you solve NPR? Okay, so question third. What we have to calculate the value of 8 factorial upon 6 factorial into 2 factorial. 8 factorial upon 6 factorial into 2 factorial. This is the value. Okay, 6 into 2, 8 factorial upon. So we have to calculate it. How can we calculate it? Because there is the multiplication and division is involved there. So you can cancel out factorial from numerator and denominator. So just convert it in factorial notation. 8 can be written 8 into 7 into 6 factorial. 1, 2, 3, 4, 5 up to 6, then 7, then 8, 6 factorial. Upon here 6 factorial is also available and 2 factorial means 2 into 1. So 6 factorial cancel. So we can write 8 into 7, 56 upon 2. So this is 28 solved. So this is the technique of solving factorial notation. Okay, so 28. Now question 4 is given here. How? 1 by 6, 1 by 7, x by 8 factorial, find the x. Okay, so question 4 is given also. Question 4. 4 is given. How? 4 is given if we are given for 6 and 7. 6 factorial plus 1 upon 7 factorial equals to x upon 8 factorial. There is x involved. This is given. Now we have to solve this and find factorial, value of x. So here, very simple solving this, because just we can say that this 6 factorial, 7 factorial, 8 factorial, these two greater factorial can be written in terms of 6 factorial. How? 6 factorial plus 1 upon 7 into 6 factorial equals to x upon 8 into 7 into 6 factorial. So 6 factorial is common on both sides, 1 by 6 factorial. So we can write 1 plus 1 upon 7 equals to 1 upon 6 factorial into x upon 56. Okay, 1 by 6 factorial, 1 by 6 factorial cancel out from both sides. So here, after taking LCM, 7 and 1, 8 by 7, 8 by 7 is equals to x by 56. So we can write x equals to 8 into 56 upon 7. X equals to 8 into 56 by 7. Okay, so 7 is 8 and what? 64. 64. So 64 is the value of x. So this is the technique of solving. Okay, question 5. Here, just evaluate factorial of n minus r 6, 2 and 9, 5. Just for calculating, just you can do it. Okay, so this was the question 4 and now question 5. Question 5. Question 5 can be solved like this. We have to find the value of n factorial upon n minus r factorial. Value of this when r equals to 6 and n equal to 6 and r equals to 2, where n is greater value and r is less than or equal n. So n is 6 and r is 2. N is 6 upon r is 2. 6 minus 2 factorial. N is 6, r is 2. So this is the value. 6 factorial upon here 4 factorial. So it can be solved. 6 into 5 into 4 factorial upon 4 factorial. These two are cancelled. Then this is value of 30. Very simple. So in a similar fashion, you can find the second 9 and 5. Okay. So also you can find the value of if n equals to what? 9. R equals to what? 5. Then 30 first value. Second, what will be the value of that? Here 9 factorial upon 9 minus 5. So 9 factorial upon 4 factorial. So we can write 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial. 4 factorial cancel. 72 into 46. Okay, this cancel and multiplication of this. Now 42 means what? Into 72. Okay, so here 72 into 21 means what? 72 into 'So this is the answer. Okay, just for calculation, this exercise is 1512030. Clear? So this is the technique for solving factorial notation. Okay. So exercise 7.2 is given for practice of calculating factorial, value of factorial. Okay. Now we know permutation. What is permutation? Arrangements of R objects from n distinct NPR. This is what? Number of arrangements. Number of arrangements of R objects from n distinct objects repetition not allowed. Okay, not allowed. That is what? NPR equals to n minus 1, n minus 2 up to n minus r plus 1. This. We can write this value in terms of factorial. Just n minus 1, n minus 2, the value n minus r minus 1 is this total value. If we divide it by n minus r factorial, it's means divide it and multiply it Okay, n minus r factorial. R is less than equal n. Here, just do it. Then r is less than equal n. Okay, just multiply in numerator and denominator. Here we can see that what is the value? n minus 1, n minus 2 up to n minus r minus 1, just it is increase 1, 0, 1, 2, r minus 1. Next value is r. So n minus r, next value, and then n minus r plus 1, r plus 2, and after ending we can get the value as 1, because this is n minus r factorial means what? From 1 to n minus r factorial means what? 1 into 2 into 3 up to what? N minus r. So n minus r, the one less value, one less value, one less value, one less value. Just this n minus r one less value, one less value, one less value up to 1. So n minus r plus 1 up to 1 upon what? N minus r factorial. So we can write what? 1 to n, that is what? N factorial upon n minus r factorial, NPR equals to. This is formula. NPR equals to arrangements of R objects from n distinct objects, repetition not allowed. Factorial n upon n minus r. Yeah. Just like, suppose we want to find the number of arrangements of two objects from given 5 distinct objects. Repetition not allowed. Okay. So, from 5 we have to take 2 objects. Formula is this. So 5 P2 means what? Arrangement in a definite order of 2 objects taken from 5 objects. This is what? 5 factorial upon 5 minus 2 factorial equals to 5 factorial upon 3 factorial. Means 5 into 4 into 3 factorial upon 3 factorial equal to 20. So number of arrangements of 2 objects from distinct 5 objects. Clear? So this is the formula for NPR. Okay. Now we want to find the value of, suppose repetition is allowed. Repetition is allowed. Then what? NPR is equals to repetition is allowed, means R places can be filled with n objects up to r times. How many times? R times. That is n to the power r. If repetition is allowed, then NPR equals to what? N to the power r. What? Arrangements of R objects from n distinct objects, but repetition allowed, then n to the power r. Because R places can be filled by 1 by 1 by taking R objects because repetition allowed. So n objects are available all times. So n into n up to r times, n to the power r. Repetition allowed. Then clear? So this is the permutation. Now suppose objects are not distinct. All the objects are not distinct. Okay? Objects are not distinct. That means maybe suppose there are 3 objects A and B. Objects 3. But here 2 objects are same, A. This is 1, 1, 9. 1, 1, 9. So 1, 1 are same. This type of objects may be. So objects are not distinct. Then how can we find the number of arrangements in a definite order? Clear? So suppose we are having n objects, of which p objects are same type. P2 objects are also same other type. And remaining are distinct. Then means just like this. Two objects are like this, B, B and C, D. 1, 2, 3, 4, 5, 6 objects are there. Two are same. Also these two are same. So this P1 equals to 2. P2 equals to 2. And these things are also 2. 6 objects are there. If in this type of objects are given, then number of arrangements in a definite order can be found by n factorial upon P1 factorial, P1 factorial, P2 factorial, just this. Okay. Means same number of objects. How many objects are same? P1. How many objects are same but other type? P2. Then just factorial of P1 and factorial of P2. Just divide overall n factorial. Okay. Can find by using this. Number of arrangements in a definite order can be found by using this, where n objects are given, of which P1 are same type, P2 are other same type, and remaining are distinct. Then you can find the number of arrangements like this by using this. Okay, so note down this formula also. Clear? Now we will solve exercise 7.3. So take first and second questions. Okay. So here take some questions from exercise 7.3. Question first. 7.3. So given question is, how many 3-digit number can be formed by using the digits 1 to 9 if no digits is repeated? Repetition is not allowed. Number digits are from 1 to 9. And how many 3 digits number can be formed? Here given digits are what? 1, 2, 3 up to 9. Clear? One, 2, 3, 4, 5. Just you can write total 4, 5, 6, 7, 8, 9. Okay, this digits are given. We have to make 3 digits number. Okay, 3 digits number. Since digits are distinct and no digit is repeated is to be repeated. No digit is to be repeated. So repeated, therefore three digits out of 9 digits can be arranged in a definite order in 9p3 ways, that is 9p3 is equals to 9 factorial upon 9 minus 3, 6 factorial equals to 9 into 8 into 7 into 6 factorial upon 6 factorial. This is equals to what? 504. So this ways. Okay. So number of 3 digits can be formed is 504. So this is the solution of 504 7.3. Okay, so this is the technique of writing. Okay, so here all objects are distinct and we have to make 3-digit number. So 3-digit number can be made, that means 3 places can be filled out of this 9 digits. No digit is to be repeated, not the repetition not allowed. So that is 93. So 93 can be solved like this. Okay. Similarly, questions 2 of 7.3. How many 4 digits number are there with no digit repeated? 4-digit numbers. Just write how many 4-digit numbers are there with no digit repeated. Just same questions like this, but here we know digits are like this. 0 is also a digit, so these are 10 digits are there. Okay, question 2. Question 2. Since digits are distinct, all digits distinct, and no digit is to be repeated also in these questions, therefore 4 digit out of 10 digits, out of 10 digit can be arranged in a definite order in 10p4 ways. That is what? 10p4. 10 factorial upon 10 minus 4 factorial. Okay. Number of 4 digits. Number. 4 digits. Number. 4 digits. Numbers. Number of 4-digit numbers can be formed is what? 10 factorial means 10 into 9 into 8 into 7 into 6 factorial upon 6 factorial. So we can solve 90 into 56 upon 1. Five zero four zero. Okay. 4536 7.3 4 digits number. Now this is number of 4 digits numbers 5040, but here one thing is important, that from these 4 digits, here we have to write like this. In this number, the numbers in which first place is filled with 0, first place is filled with 0 is also involved. Okay, so when we fill first place with 0, not repetition is not allowed. So 0 for further time, 0 is not available. So there are 9 digits. So these three places, first place is filled with 0, this is fixed, and remaining 3 places are filled with remaining 9 digits. That is 9p3. That means this is the number of digits in which first digit is 0. That is 3 digits number. So such type of combination we have to subtract from that. Okay, but in the above calculation, those 4 digits numbers are also included in which first digit is filled, first digit is 0. First digit is 0. Also included in this. So this type of digits are, this type of four digits number are actually of 3 digits number. So we have to subtract this type of number of digits, and which are given by and which are given by 9p3, which are given by 9p3 is equals to 9 factorial upon 9 minus 3, 6 factorial equals to 9 factorial upon 6 factorial equals to 9 into 8 into 7 into 6 factorial upon 6 factorial. This is equals to what? 7504. Thus, finally, the four digits numbers can be formed in 10p4 minus 9p3 is equals to what? 10p4 means 5040 minus 504. So it can be solved. 4 means 6, 3, 5436. What? 4536. 4536. Okay. 4536. 4536. 4536. So this is the number. Clear? Means this is the reason. Because first of all, just we have to take 4 digits from 10 digits, in which 0 is also available for first place. So in those numbers in which first digit is 0, that is actually 3-digit number, but we require 4-digit numbers. So that type of digits should be number of that type of digits should be subtracted from total, that is 10p4 minus 9p3. 5040 minus 504 is 4563. So this is the answer of question second. 7.3 second 4536. Okay, 4536. Just applying the formula NP, R and N to the power R. Repetition allowed, repetition not allowed. Just try to solve the questions of examples. Also important. Just I am doing generally all the questions from exercise, and some questions are given also in example. Examples are very important also. So just do 4-5 questions from examples. Just do all the examples in your copy. Okay, also, and also do the exercise, question of exercise, and send me PDF file of at least 3-4 questions from examples before 7.3 exercise for your attendance. Okay.